phenols topic of second year or 12th standard. We were studying the methods of preparation in the previous video. Now let us go for properties of phenol. Properties of phenols. Almost all phenols show similar properties because of the OH group directly attached to the benzene ring. When you compare the properties of phenol with alcohols, alcohols can undergo reactions in which carbon-oxygen bond is cleaved or oxygen-hydrogen bond is cleaved, or overall the molecule of the alcohol itself is involved. Here we observe the properties of the phenol slightly different from those of alcohols because OH group is directly attached to the benzene ring. The first important difference between the phenol and the alcohols is phenols are acidic in nature. Acidic in nature. This acidic in nature can be shown, acidic nature of the phenols can be shown by various reactions like the reaction with the sodium hydroxide to form the salt. Any compound which is acidic in nature will react with the base to give rise to salt and water. Similarly, phenols are acidic in nature. Their aqueous solutions show the acidic character to the litmus paper. That is, blue litmus paper changes to the red. But phenol is weakly acidic, that's why it will not liberate the carbon dioxide from sodium carbonate or bicarbonate. So that is the important difference between acidic substance and acidic nature substance. Acids liberate carbon dioxide from the sodium bicarbonate. For example, when you take this stick acid, CS3COOH, it is acidic. It is an acid. When you treat with this sodium bicarbonate, it will liberate the carbon dioxide. Effervescence of carbon dioxide. But when you take this phenol, react with this sodium bicarbonate, there will be no liberation of carbon dioxide. So this is weakly acidic as compared to the sodium bicarbonate or carbonic acid. That's why phenol shows acidic nature, but it will not liberate the carbon dioxide from sodium bicarbonate. This important difference you have to remember. Now coming to this acidic nature, they will react with bases to give rise to salt. The aqueous solutions are acidic to the litmus paper. The second one is the phenols show properties due to benzene ring. Properties due to benzene ring. Because of aromatic nature of the benzene ring, they undergo aromatic substitution reactions. But some reactions are similar to those of alcohols. That's why we will categorize the properties of phenols into three types. One type similar to those of alcohols. The second one acidic character, but they are weakly acidic, that's why they do not liberate this carbon dioxide from the sodium bicarbonate, and properties due to benzene ring. And overall, because of the OH group as well as benzene ring, they undergo some other reactions. So first let us consider this phenol with sodium hydroxide with NaOH. When you consider the reaction with NaOH, as I told you, it behaves like an acid. That's why it gives rise to C6H5OH plus NaOH. It gives rise to sodium phenate. Sodium phenate C6H5ONa along with the formation of water. But when you take this with sodium metal itself, dry sodium metal, always the sodium is kept under kerosene to avoid the reaction with the atmospheric moisture. That's why when you take out from the kerosene, it should be dried. When that sodium metal, dried sodium metal is treated with this phenol, it will liberate the hydrogen gas, forming the sodium phenate along with the liberation of hydrogen gas. If you take 2 molecules of phenol, 2 molecules of sodium metal, it will give rise to 2 molecules of sodium phenate with hydrogen gas. But we can also balance in this way. When sodium metal is added to phenol, it will liberate the hydrogen gas. This reaction is similar to those of alcohols. Okay. The next one is, this is acidic character. The next one is with acetyl chloride. Acetyl chloride. Acetyl chloride is actually CH3COCl. When you react this in presence of sodium hydroxide, phenol plus acetyl chloride, ClCOCS3, it will give rise to CH3COO C6H5. This is called phenyl acetate. Phenyl acetate. Similarly, when you treat this with benzoyl chloride, benzoyl chloride is C6H5COCl. CH3COCl is acetyl chloride. C6H5COCl is benzoyl chloride, again in presence of sodium hydroxide. It will form same type of reaction, C6H5OH plus ClCOCS3 C6H5. It will give rise to phenyl benzoate, C6H5 COO C6H5. Remember, this phenyl group is from phenol. This phenyl group is from benzoyl chloride. C6H5COO C6H5 plus NaCl, of course. Plus NaCl and water. This reaction is named as the, I will write the name here, Schotten-Baumann reaction. Schotten-Baumann reaction. It is with acetyl chloride and benzoyl chloride, it will undergo acylation reaction. In place of the hydrogen atom of the phenol, acetyl group or benzoyl group is substituted. But particularly this reaction is named as the Schotten-Baumann reaction.